Good day everyone, my name is Katrina Pidinalan and I'm going to discuss about an optimization problem. So, let's get started. I have here a problem that find two numbers such that the sum of the first and twice the second is 100 and their product is a maximum. So, x is equal to first and y is equal to second. So we have to find the equation using the question of the problem. So our equation will be x is equal to 100 minus 2y. And then the next step is we have to identify the constraint and the objective function. So the constraint is equal to a fixed value, that is x plus 2y is equal to 100. And our objective function or objective equation will be f of x is equal to xy. So then we have to isolate the x in the constraint equation, which is now x is equal to 100 minus 2y, and then we substitute it to the objective equation, which is f of x is equal to 100 minus 2y. And then we distribute the y, so it will become f of x is equal to 100y minus 2y squared. And we get or solve the derivative, which is x is equal to 100 minus 4y. And then we equate to 0 to be able for us to get the critical number. So it is equal to 100 minus 4y is equal to 0. So 100 over 4 is equal to 4y over 4. We cancel the 4 at the other side, and then we divide 100 to 4, which is equal to 25. So y is equal to 25. Then we proceed to our next step, which is to substitute the answer of y to the isolated equation of x, which is x is equal to 100 minus 2y. And then we solve for it. So x is equal to 100 minus 2 times 25. The 25 is the answer of y. So 2 times 25 is equal to 50. 100 minus 50 is the answer will be x is equal to 50. And for the last step is that we substitute the answer of objective function. Again, the objective function is f of x is equal to xy. So f of x is equal to 25 times 50. 25 times 50 is equal to 1250. And now that is our maximum product.
A box with a square base has no top. If a 48 cm squared of material is used, what is the maximum possible volume of the base? Our solution: x is for squared base, y is for the height, and v is for the volume. And our constraint function is x squared plus 4xy equals 48 cm squared. And our objective function is v equals x squared times y. Solve for y in terms of x. X squared plus 4xy equals 48. Transfer x squared to the right side, and we get 4xy equals 48 minus x squared. Divide both sides by 4x, and we get y equals 48 minus x squared over 4x. Substitute equation 1 to the objective function. V equals x squared times y, and v x squared times 48 over 4x minus x minus 4x. And we get v equals 12x minus x cubed over 4x. v equals 12x minus x to the power of 3 divided by 4x. v equals 12 minus 4, the quantity of d over dx, times x to the power of 3 minus x to the power of 3 d over dx times 4 divided by 4 squared. In the first equation, we must use the power rule, and the second is the constant rule. And we get 12 minus 4, the quantity of 3x squared minus x to the power of 3 times 0 divided by 16. Then we get 12 minus 12x squared divided by 16. Reduce it to its lowest term, and we get 12 minus 3x squared divided by 4. Equate it to 0 and transfer 3x squared divided by 4 to the left side, and divide both sides by 3, and we get x squared equals 48 divided by 3. Extract square roots to get rid of the power to the power of second, and we get x equals 4 cm.
That's all, and thank you for watching.